Unit 7, learning target number 13. Find the volume of prisms using the formula V equals BH, or volume is equal to base times height. In our last video, we talked about finding the volume of a rectangular prism. Rectangular prism being a rectangle that's kind of a cube, maybe that's stretched on one end. So we had this nice rectangular shape here. And we said that if we had, this side was 6 inches, and this side was 2, and this side was 4, we had our length and our width and our height, and we just multiplied those together, length times width times height, and we would get our dimensions, our volume here. So we have 6 times 2 times 4, and we could multiply these two together. For example, we multiply that by 6 and we get 48, and that would be the volume of our rectangular prism. Today we're going to talk about the formula that's used for any prism. This is a formula that's specific to rectangular prisms. But now here we have a triangular prism. It's triangular because it has a triangle on one end here, right? So we want to learn how to find volume for any prism. What if we had a prism that had a pentagon on the end, and then it extended out like that, and we needed to find the volume for that guy? We can use volume is equal to base times height to find the area of any prism. Okay, so let's try it out. We're going to calculate the amount of chocolate a Toblerone wrapper will hold. We saw this last time. This little chocolate bar that's in the shape of like a triangle that's been stretched out really long. And that is exactly, by the way, we usually use a capital B for base. That is exactly what we're going to be doing. We're going to be finding the area of this right here, of this triangle, and then we're going to multiply that by the length of the chocolate itself, or the package in this case. So let's find the area of this piece right here. Let's find the area of our triangular face. We know that area of a triangle is equal to, we'll put triangle there to show that that's what we're finding. Area of a triangle is 1/2 times base times height. Now this base right here is a different kind of base than this base, and we'll find out why that's the case in just a second. But the base that we're looking at is not this base, this line, which is, when we're talking about this lowercase b base, we're talking about this little line right here, the base of the triangle. When we're talking about this base, that is this whole face. The capital B base is this whole triangular face here. Alright, so let's get started. 1/2 times the base times the height. We have 1/2, and we know our base is 1 1/2 inches. So times 1 1/2. And then we're going to multiply that by 1. So that's pretty easy. We know that 1/2 times 1 is just 1, 1 1/2 times 1 is just 1 1/2. And we're going to multiply that by 1/2. Now you can probably figure that out in your head, but let's go ahead and do the calculations here. That's 1/2 times, and then we'll convert our mixed number to an improper fraction. 2 times 1 is 2, plus 1 is 3 over 2. All right, and then we multiply those together. So we convert 1 1/2 to a mixed number, and we get 3 over 2. And we multiply those out. 1 times 3 is 3. 2 times 2 is 4. Remember, top times top, bottom times bottom. We get 3/4. 3/4 inches squared is the area of this whole triangle right here. That's the area of that triangle. Now, that is the base right there that we just found. We found the base. Now we need to find the height. Well, the height has been given to us. It's right here. It says the height is 6 inches. That is the height of this entire triangular prism. It is the distance of how far we're going to stretch this triangle, how far we're going to extend it out this way. So we multiply that by the base. So this is 6 inches. I'll put this in a different color here. We'll do volume is equal to base times height. So we have the base, which we said was 3/4 inches squared. So we'll multiply that 3/4 by the height, which we said was the length of the whole triangle, of the whole triangular prism, and that was 6. And then we'll do basically just fractional multiplication. 3/4 times 6 over 1. Remember that any constant is just itself over 1. 3 times 6 is 18. 4 times 1 is 4. And then we'll convert that back to a mixed number. 4 goes into 18 4 times, because 4 times 4 is 16, and that leaves 2 left over, which is 2/4. Or, if we want to, we can say 4 1/2. Our area of our entire, our volume of our entire triangular prism is 4 1/2 inches cubed. 4 1/2 inches cubed. Now, our formula for volume there, V equals base times height, is really helpful when we have problems like this. You don't know the formula yet for how to find the area of a pentagon. And this side is a pentagon right here. As you can see, it's got 5 sides. But you do know base times height. So in this case, they've given us the area of the base. We can tell because it's in meters squared. And we know that the formula is V equals BH. So we know that the base is 20 meters squared. And we know that the height is 2 meters. And so we can find the volume by simply multiplying those together. And our volume then is 40 meters what? It's meters cubed because it is volume. Please remember that volume is in meters cubed. Here's another one. In this case, we have a hexagon here. We have 6 sides. 1, 2, 3, 4, 5, 6. And this time we need to find the volume of that one. Well, fortunately, the volume formula does not change. We use the same thing. We've got our base. We're told that that is area, and it's in centimeters squared, so we know it's area. 10 centimeters squared. And our height of the pyramid, now notice this, the pyramid is sideways, but we still consider that the height. We're going to multiply that by 4, and that will be our volume. So that will give us 40. And 40 what? 40 centimeters cubed. And that will work for any prism.